any form, but silicon and tin react with steam at red heat to form the positive 4-state oxide and hydrogen. Silicon solid plus 2 molecules of water gas to give silicon oxide plus 2 molecules of hydrogen. Lead forms lead-2 hydroxide with unrated water carbon silicon, and tin form positive 4-state oxide when heated strongly in air or oxygen. Lead forms lead-2 oxide on heating in air. Group 5. Nitrogen and phosphorus belongs to group 5 and exhibit very similar properties. They are non-metals and show two common valency of 3 and 5. They are electron acceptors and both form several oxides of which have parallel characteristics. Examples are nitrogen 3 oxide N2O3, phosphorus 3 oxide P4O6, nitrogen 4 oxide N2O5, and phosphorus 4 oxide P4O10. All these oxides are acidic and will combine with water to form acid. Nitrogen and phosphorus also form similar hydrides NH3 and BH3, and chloride NCl3 and PCl3. Group 6. Elements in group 6 include oxygen, sulfur, which are non-metals. They are electron acceptors and are oxidizing in nature. For example, 2 molecules of manganese solid plus 1 molecule of oxygen to give 2 molecules of magnesium, 2 ion and oxygen negative ion. Ion, that is Fe, plus sulfur X to give ion, which valency is 2 positive, and the valency of sulfur is 2 negative. Oxygen is lightly soluble in water while sulfur is insoluble. Both elements do not attack water in any form. Both oxygen and sulfur combine directly with hydrogen to yield water and hydrogen sulfide respectively. 2 molecules of hydrogen gas plus 1 molecule of oxygen gas to give 2 molecules of water. 1 molecule of hydrogen gas plus 1 molecule of sulfur solid to give 1 molecule of sulfur hydrogen sulfide. Group 7. The elements in group 7 are known as the halogens. The word halogen means salt former. They are the most reactive non-metals known and are reactive with other elements in the environment. That in nature they exist mainly as salt rather than free elements. Halogens show great similarities in their property because each of their atoms has the same number of valence electrons, that is 7. Some of these similarities are as follows. They are all non-metals. They exist as diatomic molecules. They are colored. They are noised to form univalent negative ion which react with metallic ions to form electrovalent compound. The hydrides are covalent gas at room temperature and dissolve readily in water to form acid. The halogens also show a graduation in their property from fluorine to iodine due to progressive increase in their atomic number and the complex of their atomic structure. The following trends are exhibited by the halogens as we go down the group from fluorine to iodine. 1. Change in state. At 25 degrees centigrade, fluorine and chlorine are gases. Bromine is a liquid and iodine is a solid. 2. Their colors become darker. Fluorine is yellow, chlorine is greenish yellow, bromine is reddish brown, iodine is black. 3. Their melting point and boiling point increase progressively. 4. The ease with which the ionize to form negative ion decreases, that is, the electronegativity decreases. This is reflected by decrease in their chemical reactivity. For example, in reaction with hydrogen to form hydride, fluorine reacts explosively in the dark. Chlorine reacts slowly in diffuse light but explosively in bright light. Bromine slowly in bright light and iodine slowly and incompletely even in bright light. In displacement reaction, each halogen displaces one another following it from a solution of letter salt and as shown below. Fluorine plus 1 molecule of gaseous fluorine plus 2 molecule of sodium chloride aqueous to give 2 molecules of sodium fluorine aqueous plus chlorine gas. 1 molecule of chlorine gas plus 2 molecules of sodium bromide aqueous to give 2 molecules of sodium chloride plus bromine. 1 molecule of bromine. 1 molecule of bromine gas plus 2 molecules of sodium iodide to give 2 molecules of sodium bromide aqueous plus 1 molecule of iodine gas. Group 0. The elements in group 0 are known as rare gas or noble gas. They have no bonding electrons in their atomos shell. Hence, the group is named 0. The elements include helium, neon, argon, krypton, xenon, and radon, which is radioactive. Because of their unreactivity, they form few compounds and exist freely, that is, uncombined as monoatomic molecules in the atmosphere. They constitute about 1% of the composition of air. Their unreactive nature can readily be understood from their electronic configuration, which satisfy the octet rule for stability. The noble gas shows very similar property among themselves. They bear no resemblance of the halogens. They come before them and alkali metal that come after them, and so mark the end of each period very appropriately. The noble gas exhibits a graduation in physical properties which relate to the progressive increase in the atomic number. Thus, their melting and boiling points increases while the ionization energy decreases down the group from helium to radium. Transition elements. Between group 2 and 3 is collection of elements which show similar behavior. These are transition elements. Transition elements are all metals with typical metallic properties such as high tensile strength and high melting points. They have variable valencies and their ions are colored, and they have the ability to form complex ions. Many transition metals like iron, copper, silver, and gold are of commercial importance. Some like magnesium and nickel are industrial catalysts.